Hey, curious minds, welcome back with one more new video on Decode Dataverse Journey with Tina, where we simplify one concept at a time. If you're new here, make sure you subscribe so that you'll never miss an update on your data journey. Today's topic is about the code rules which he gave to design a DBMS software. If you haven't seen my video, the real story behind databases, watch that first. It will help you understand why these tools were created in the first place. You'll find a link up right on the video or down in the description because understanding that story will make today's topic crystal clear. So, let's talk about Dr. E.F. Scott, the father of relational database. He had created 12 rules that defines what a true relational database management system should follow. It says 12, but there are 13 following with the foundational rule. As you see on the screen, the rule starts with rule number 0, the foundational rule. Think of these principles that make databases organized, reliable, and efficient. The very reason systems like SQL Server, Oracle, and MySQL works that way they do today. So don't worry if you are not technical. I'll explain each rule in simple language with real life example so it all makes you clear. So we'll go with the first rule. Rule number 0, the foundational rule. It says that for any system that is advertised as or claimed to be a relational database management system, that system must be able to manage databases entirely through relational capabilities. So I'll explain. For example, rule number 0, if you call a car electrical, then it should run completely on electricity. It should not be like hybrid, like using petrol and using with electricity. So likewise, if a system claims to be relational, it must be doing everything the relational way. No shortcuts, no mixing systems. Next rule. Rule number 1, the information rule. It says that all information in a relational database is represented explicitly at the logical level and in exactly one way by values in table. So imagine, rule 1. Imagine an Excel sheet. What do you do with Excel sheet? Where you store everything like name, phone numbers, emails. Everything you store exists neatly in rows and columns. So there is no hidden information in files or secret folders. Everything lives in one table with rows and columns itself. So this was the information rule. So next comes to rule number 2, the guaranteed access rule. It says that each and every dot term means atomic value in a relational database is guaranteed to be logically accessible by restoring to a combination of table name, primary key value, and column name. So, I tell you in simple words, imagine so if you want to write a house address, how will you write? So every piece of data has a clear location. So think table name as street name, column as house number, and key as door. So you can find anything without confusion. So this is what the rule 2 is. So next comes to rule 3, a systematic treatment of null values. So as given, null values distinct from the empty character string or a string of blank characters and distinct from 0 or any other number. So what are null values? Means it's an empty string. Like if you give something and you forgot to give a detail or data into that table or row, it's a null value. So here the rule 3 says null values are supported in a fully relational DBMS for representing missing information and inapplicable information in a systematic way independent of data types. So to make you understand what rule 3 is, if a person's phone number isn't known, so we put, if we don't know and leave it blank, we don't put like 0 or any. So if this blank does not mean 0, it means unknown. That's exactly what null stands for. Understand? So next is rule number 4, dynamic online catalog based on relational model. It says the database description is represented at the logical level in the same way as ordinary data, so that authorized users can apply the same relational language to its interrogation as they apply to regular data. So this means that to make you understand in a simple language, rule 4 says imagine a library. So what a library does, that also keeps a book about how the library is organized, and you can also look up just like any other book, right? So that's what a data catalog does. It describes database using the same language you use to query. Understandable? Is it understandable now? So it's just like a agenda. So next, rule number 5. The rule number 5, the comprehensive data sublanguage rule. Here the rule says a relational system may support several languages and various modes of terminal use. However, there must be at least one language whose systems are expressible per some well-defined syntax as character strings, and that is comprehensive in supporting all the following items. It should support all the following items below: data definition, view definition, data manipulation, integrity constraints, authorization, transaction boundaries. So these transaction boundaries are begin, commit, and rollback. To make you understand, I'll give you with an example. Rule number 5 says, just like English lets you talk, right? And write, and also express emotions, correct? Same way, database needs one main language. to define, manage, and secure. Secure whom? To define what? To manage what? The data. So that language is SQL. It does not it does everything from creating tables to roll back changes. And next, rule number 6, the view updating rule. It says that all views that are theoretically updatable are also updatable by the system. To make you understand rule number 6, I'll give you example. Think a filtered list, like seeing only family contacts on your phone. If you can change your brother's number in that filtered list, it should automatically update in your main list too. So, this is what updating in one system meant to be updated in the whole main system. Correct? Is it understandable now? Good. So, next is rule number 7, relational operations rule, also known as possible for high level insert, update, and delete. The rule says the capability of handling a base relation or a derived relation as a single operand applies not only the retrieval of data but also to insertion, update, and deletion of data. To make you understand, I'll give you a simple example. Rule 7. So, instead of editing one contact at a time, you can update all your work contacts in one go. That's batch processing. Relational databases are built to handle large set of data at a time. This is what the rule says. It should manage, insert, update, and delete. You'll come to know in the future videos about what's the rule belongs, what is about insert, what is about update, and what is delete. Next is rule number 8. Physical data independence. It says that application programs and terminal activities remain logical unimpaired whenever any changes are made in either storage representations or access mode. To make you understand this rule, I'll give you an example. Rule 8. It's like rearranging your living room. So, whenever your guests still know where the TV and couch are, the behind scenes setup changes, but however the people interacts with it stays the same. This is what the rule 8 is. We make the changes in the living room, but it cannot be seen by the guest. Understandable now? Good. Next rule number 9, logical data independence. The rule says application programs and terminal activities remain logically unimpaired when information preservation changes of any kind that theoretically permits unimpairment are made to the base tables. So, to explain, I'll give you an example for rule 9. You rename your friends' contact list to close friends. So, your phone's messaging app still finds everyone. The logic change, but it does not break your experience, right? So friends to close friends. But in messaging is same. It does not affect anything or break the experience. Understandable? Good. So rule number 10. Integrity independence. It says that integrity constraints specific to a particular relational database must be definable in the relational data sublanguage and storable in the catalog, not in the application programs. So what this means is, think of automatic spelling check in Word. You don't have to fix typos yourself, correct? So similarly, database enforce their own rules for data, like preventing duplicate IDs or invalid date automatically. So this is what integrity depends. We do have specific constraints we'll look in the future videos. Next is rule number 11. Distribution independence. It says that the end user must not be able to see that the data is distributed over various locations. Here, users should always get the impression that data is located at one site only. It says that when you open Google Photos, for suppose, just giving you example, your pictures might live in the server across the world, but to you it feels one smooth album, correct? That's the distribution of independence. So next comes to the last rule, rule number 12. The non-subversion rule. It says that if a relational system has a low-level language, that low level cannot be used to subvert or bypass the integrity rules and constraints expressed in the high-level relational language. To make you understand what's this rule with a simple example, rule number 12. Even if you have admin access, you are in an IT company, and even if you have admin access, you can't secretly change your salary in the HR system, right? Will you change that in the HR system? No. So it's about breaking the rules. The system prevents you from breaking the rules no matter how you try to do it. This is what the rule 12 says. So that's wrap on the court's 13 rules, the rule book that made modern database reliable, structurable, structured, and powerful. So here's a quick recap what we learned. We learned rule 0 to 12, define how a true relational database should behave, and these rules make sure your data is consistent, accessible, and safe. That's a wrap for this video, and watch out for my coming up series of this SQL Server or SQL Server. We will start applying these ideas in the real examples. Keep exploring, keep asking questions, keep decoding. To all my written data champs, you're doing amazing. And if you find this video helpful, don't forget to like, share, and subscribe. my data champions, you're doing wonderful. So this is your Tina decoding with you. Until next time, keep your data adventures alive.